Hello. So we are back, and this time we have an interesting job. Yeah, this is not a comeback job, but it is. This job was previous fixed here. The computer was previous fixed here. So let's check the customer email. So what the customer is saying, I fixed his NUC fundless PC on 9 of May 2024. So you see, this is a happy customer. So actually, I found a video where I fix this PC. The laptop died by inverse voltage, so was a shorted diode, and we replaced the diode with another one. Of course, I didn't have the original one, and I believe, but that's what I believe. Yeah, I believe the customer is trying to tell me something with this package. I mean, far away from me to make fun from the customer. Yeah, but I get crazy packaging. And this one probably it's on the top of every packaging I received before. Now I'm assuming this is actually, the black British humor. Maybe I'm wrong, maybe I'm wrong. So I do you think actually the customer is trying to tell me something? You know what? I'm not gonna send this back. No, I'm gonna wrap the computer in bubble wrap, and actually we are making some money. Actually, we are saving some money because toilet paper is more expensive compared with bubble wrap. Or maybe the customer is trying to tell us actually the previous job was a shit job. Uh, anyway, Diana said we need toilet paper. Yeah, that's a funny one. Yeah, yeah. Okay. Let's try to have a look at the customer computer. I didn't have a good laugh from long time, but anyway, what's the problem with the mini PC right now? The customer said, "Thanks for agreeing fixing this again. Beside the USB-C port being burned, once of the wire going onto the Wi-Fi card broke." Okay, so we have a because the customer sent me actually the port which has to be replaced. If the USB port doesn't fix the PC, wait, actually the PC is dead because a port is no reason for the PC actually, being not working. I'm willing to pay more. No, don't worry, I will keep the toilet paper. Yeah, a gentleman called Mike. Okay, let's try to have a look. Oh yeah, definitely this port is gone. Check that. Huh? Yeah, I believe that port is gone, but that's no reason for the computer actually to not work. So I'm not sure how we should proceed with further. We should test it or actually open and check first. I will say let's open and check first. And the mini PC it's open. The Wi-Fi wire indeed is broke. Yeah. Should work fine even with one. That's no issue. My diode is still there. You can see it. Yeah. Let's plug the power and see what it's doing. I'm gonna lower the current, but not too much. Good. Let me grab a adapter. Plug in the charger, and no, it's not shorted. Actually, it's okay. It's fine. Pressing the power button, but it's not coming on. Ha! Okay, that sucks. No. No, it's taking like 70 milliamps, 80, but it's not coming on. Yeah, so definitely it's not only the port. Let's say the port is faulty, it's not only the port. And you know my concern is this wire is broken. This wire has ground here. If the ground touch the board, then the computer dies. Just to prove the point, yeah? So check here. Ground from the charging port, we ground here. Check there, 0 ohms. So this wire has ground because the ground is coming from the metallic case. So if the wire touch anywhere on the board, yeah, it is possible the board died. Okay, let's try to take the board out. Not sure if I said that before, but I love the design. You know, no fan actually. No noise. And just a big heatsink. And the mini PC, it's out. Let's check the main power rail first to be sure it's not shorted. We have a bunch of capacitors here. And the main power rail is not shorted. Okay. Let me take out the M2 drive and the Wi-Fi antenna. Good. So we have one port which is faulty, which is this one. Okay. Plug in the power. Good. Pressing the power button, which is here. Nothing happened. Which is strange. Why the EC chip is not reading the power button? Because the current is not changing at all. We can unplug the BIOS battery just to be sure we don't have like a frozen EC chip there. Pressing the power button, nothing. Okay, let's check the main power rail. I'm gonna zoom more onto the board. So checking the main power rail. And we have 19.9, check that. So the main power rail is present. Then let's check the power button. Let's go under the microscope. And the power button is here. But not sure if the pins are actually the pins which they are switching. Okay, they are not. So on this side, let's see. Here we have 3.2. Here we have 0. Okay, that's bad. Pressing the power button and the voltage, it is going to 0. You can see that? Huh. Yeah, it is bad. Okay. Then the next logical step is to check the coils. So the coils, this one is good. This one has 0 ohms. CPU, good. 5 ohms. 5. Why this coil has 0 ohms? This one is good. This one is good. No. What? Yeah, it is good. Yeah. But I'm not happy with this one. This one is 0 ohms. What that coil is doing? Oh, that sucks. So this is the chipset power rail. Huh. How the chipset died? Yeah. Because of the charging port. Because the data lines, I mean, the data lines should not come straight here. Because we have these Intel high-speed communication chips, yeah, Thunderbolt chips. So the data lines are not coming straight to the CPU from here. Yeah, they are coming to the CPU, and it's very strange because like we have no short, right? That means the all monolithic drivers, and those are good monolithic drivers. So even if I have a shorted monolithic driver, the output it will still be protected. So we have no shorted monolithic driver, but still the chipset is shorted. Let me bring the thermal camera. Okay, so we have the thermal camera on the screen. And I'm gonna come with voltage. 1 volt exactly on this coil. And it's taking 1.4 amps. And yeah, the chipset is getting hot. Check that. It's getting hot on one side. So the chipset is not normal to have like 0 ohms. I don't have short anymore. Wait 1 second. We checked here. It's not short anymore. How? It's taking like 50 milliamps. Let's check with the multimeter the resistance. We have 54 ohms. That's insane. That's crazy. How the board got fixed by the power supply. Crazy, yeah. I was about to say that's the normal resistance of the chipset, around 30 up to 50. So now it's fine. And now you'll say, yes, sorry, you probably a short a capacitor on the... No. Because it was getting hot on one side, yeah? Here, inside of the capsule. No, it was not under the chipset or CPU. It was on the capsule, inside. I'm assuming if I plug the power now it's working. Let's see. So we have 19 volts. Plug in the power. Pressing the power button, which is here. No. But we fixed the chipset issue. We fixed it. No. It's not working. It's taking no current, nothing. Okay, let's see where is the EC chip. So the EC chip is here. We have a IT5571VG. We have the BIOS here. Here you have a jumper, not sure for what. Here you have the 5 volts and the 3.3 LDO, and I want to check that. So plug in the charger. Remember it was taking like 70 milliamps before? Now it's not taking, now it's taking like 14. So here we have 3.3 and here we have 5 volts. Yeah, so the LDO are present. That's the audio chip. Not sure why the audio chip it will get hot. This one. It's not getting hot, like slightly warm. And that's okay. And the chipset, let's check the chipset voltage. So the chipset voltage is 0 volts. I'm not sure if I'm happy with that. I should have like 1.8 there. If the chip is enabled, of course. Yeah, we can see the EC chip has power. You can see it on the thermal camera. And the voltage on the EC chip probably is here. Here is 0. No. Here? Yeah, 3.3. So the EC chip has power. Actually, we have power on the power button. But for some reason, the EC chip doesn't want to read the power button. No, pressing the power button, nothing happened. Where the power button is going. So here is 3.2 and it's going to this resistor. Then it's going here. Here 3.2. Pressing the power button going to 0. Yeah, it is working. Now I'm not sure what should I do from here. I mean, I really wanted to help the customer, but we had a shorted chipset. Short is gone, but you cannot just assume, okay, everything is back to normal. No. Then we have a IC chip which is not reading the power button, and I cannot replace this one. This one has to be programmed, and I cannot program that chip. Then we have a possible ground wire which could short anything on the board. That means you are searching a random fault. There are so many variables on this board. So here we have 5 volts. So the big 5 volts it is present. This is 3.3. The big 3.3 it is present. You see? So everything is fine. We don't have 1.8 here. Pressing the power button off. But this is pissing me off because the AC chip is not even trying to do something. It's actually ignoring the power button. The current is going a little bit up is because we are actually shorting the 3.3, which is coming from a pull-up resistor. We are shorting that to ground, but that's all. The AC chip is just ignoring the power button. Yeah, I can remove the port, the faulty port. I can do it if you think, something can be shorted. And that can be the reason actually why the board is not coming on. I really doubt it, but I can do it. Yeah, clearly this is a faulty port. We can remove it, but I'm pretty sure it will change absolutely nothing. And the port, it's out. Yeah. So what about now? Good. Let's plug the power again. And same story. Pressing the power button and nothing happened. No, it's not the port. No. I'm really sorry, but it's nothing what I can do here. I can order a chip from who has tools to program this chip. I can order the chip, but you can be sure actually the chipset is good. Huh? You can bet actually the chipset is good, so you will put the money on this because the customer it will not pay. You will pay. The customer it will pay for the final, final repair price. So you will get the risk to order this, which is probably around 60, 70 pound programmed. Let's not forget the wire, yeah? We'll short the board randomly. So even if you manage to bring this to life, to come on actually, you can have a surprise like no picture or different kind of stuff. I'm really sorry for this customer. I'm really, really sorry. I was hoping I can help him the second time. But this shorted chipset, turned me off. The chipset and actually the moving ground wire. Because when you have a fault and you add some randomness, you end up with a rabbit hole. Yeah. Well, I'm really sorry about this. This was one of the most funniest job ever. Like I said, I get like crazy packaging. I get like open boxes. The box is open like a laptop box. All you have to do is to pull it out and you'll see the laptop. Then I have jobs that are coming on like special cases, like that expensive special cases for, I don't know, carrying bombs or something. Yeah. Definitely, this one was the funniest one. Anyway, this is not the first time when this happened. Like you have a short, you come with current, and actually the current is burning something. And I did have cases. The current burned something and looks like everything is normal, and it was working as normal. But this one, we had a heat on one side of the chipset, and that indicated the short was exactly here. Now the short is gone, but from here to assume actually the chipset now is good, and that's not even my main issue, because even if you have a dead chipset like 0 ohms, you should see EC chip reading the power button. So you should see some current change on the when you press the power button. Like the EC chip is trying to do something, but no, the EC chip is not trying to do anything. Yeah, so I'm gonna stop here. Let me speak with the customer. I'll say thank you for watching, and like, subscribe if you like the video, and see you on the next one. Bye.